Welcome guys to a new lesson, and in this section we are going to talk about handling common file formats. So when writing scripts to control several applications or utilities, it's common to use files as the data transfer mechanism between applications. Unfortunately, the output format of one application may not be in exactly the right format for the next application to read. At this point, the script itself must convert the output file into the appropriate form for the next application to read. Most applications produce and consume variants of a few standard formats such as CSV, that is comma-separated values, HTML, hypertext markup language, XML, which is extended markup language, and we also have Windows INI files named after the file extension, and more recently JSON, which stands for JavaScript Object Notation. We will look at how Python standard library supports these various formats. JSON is covered in a later lesson, which is called Python on the Web, because it is most commonly associated with the web applications. So these modules make it easier to read and write data than if we tried to do it using the standard Python text processing tools, such as string methods or regular expressions. So now we're going to work with the CSV files, comma-separated values. The comma-separated value format has been around for many years. Its name is something of a misnomer because though commas are the most common separator, the term CSV is often applied to files using tabs or pipes, or indeed just about any other kind of character as a separator. At first glance, it might seem easy to parse data from such a file using the built-in string split method. The problem is that the format is not absolutely standardized, and different files have different ways of representing fields that contain the separator within them. Also, lines of data can sometimes be split over multiple physical lines in the file. To make dealing with this diversity easier, Python includes the CSV module in its standard library. The CSV module provides two mechanisms for reading CSV files. The simplest just reads each line into a tuple, and the programmer has to keep track of what each position in the tuple represents. The second method reads the data into a dictionary, often using the first line of the file as the keys of the dictionary. This is particularly flexible mechanism because it accommodates changes in the file format, such as adding new keys without breaking existing code. One note is that one big issue with the standard CSV module is that it does not handle Unicode input. If you need to process files containing Unicode characters, you should investigate third-party modules, such as Unicode CSV. The module defaults to the CSV format used by Microsoft Excel, but you can define your own formats too. It just takes a bit of extra work. So in this lesson, we are going to deal with the Excel format only. And the example that I'm going to use are based on a simple spreadsheet called Tool Hire XLX Excel file, this one. And I'm going to link download to that in the course, this video description of this section, so you can download it if you want. And also we need another CSV format file, which is called Tool Hire CSV, which I will also make available for download. So let's just start by opening this spreadsheet. just to let you see what's inside here. So the spreadsheet describes a small tool hire facility set up by some friends to keep track of who is borrowing what from whom. And the data was saved to a CSV format. So this is what it will look like in if we open in Excel. In Notepad, it looks a little bit different. Then you can see it's with commas. So this is a fairly simple file, but does include one of the complexities described earlier. And notice that Anne's sacrifice description is surrounded by double quotes because it contains a comma. So now we can use Python to read this data. So let me just fire up my command prompt. And it's very important to be in the correct folder when you're using with these files. Otherwise, you will just get confused. So let's see, can we file the XLS file is here, and the CSV file is here. So let's clear this up and start Python. So it prints out the contents of the CSV file. Date return. So notice that Anne's scarcifier description no longer has double quotes. Here, this part. But does still contain the original comma. Figuring out how to do that is the value that the CSV module adds to our problems. We can apply lots of options both to the file in the call to open function and in the creation of the CSV reader object. So this example shows the minimal set. So note, the reader object is not limited to files. It can also take a list of strings as input instead. So this can be a powerful tool if you are using subprocess to generate CSV format data on standard output. So writing to a CSV file is just as easy. So I'm going to show you another example where I create a new page of data for the tool hire Excel spreadsheet that lists the various tools available along with some details about when they were made available, their condition and original price. We save the data as CSV file called tool desk CSV, that we can load into Excel as a new worksheet. So there is no file tooldesk.csv here, so we're going to create it with our code. So let's create our I think it will be better if we create a new file here instead of typing it in the command prompt. To hire CSV, I can just call it something like that. Like always, I will explain in the end what is going on. Just copy this. Need 6 of those. And of course, we need date here. Fair condition and date. I'm just going to pause the video. When I'm finished, I will. When I'm finished entering the items, I'll come back again. So see you in a minute. Okay, I've just finished entering the item details. So I'll continue with the code. So one good thing with the IDE is that they give you code completion, which can be handy, so you can always check that you have your connections with the objects and everything correct. So if you see in the working folder, we have now a file called tooldesk.csv. So this will hopefully create one. So let's try to run it. So it's created a new file called tooldesk.csv. So as we can see, the writer.writeRow method returns the number of characters written in the file. And mostly we just ignore that. And because this this interpreter works a little bit different than here, that's why we didn't get the output. And also one thing to note, that the scarifier description once again has quotes around it, and the data fields and the date fields are written exactly as is. If we want to get the dates in the same format as Excel produced in the original CSV file, we need to do that manipulation before we write the data. This is very special of the kinds of inconsistencies we find when using CSV files as a transport between different applications. You can use the datetime module to convert the date formats. Datetime contains the datetime.strptime function, which can parse an input string to a datetime object, and the datetime.strftime function to write that datetime object out in the format we want. We can try that now. We will read a list of tools from the tooldesk CSV file, then extract each date field from the list, convert the format of the date, and finally write the entire data structure back to the CSV file. So let's write another function in this folder. Always when you're creating a new file in Python, just click on the folder project and then file new. If it's not highlighted, this folder, it's you will not be able to create a new file. I don't know, it's a bug or what it is, but just so that you know. So let's call this tool hire application. And the issue with this is that sometimes Excel doesn't convert the dates. So Excel has slashes. See in here. So just to make it consistent, we are trying to work with the dates. We'll create a function. Here we are converting it to so it suits Excel. Seems correct. Like always, I will explain in a second what I'm doing. So here we're going to create a new file. Let's save the file, run it. So something happened. It created a new file here in the folder called tooldesk.cv, tooldesk2.csv. So let's open it. And we see the file formats. It's now with slashes. And the original file, tooldesk, is with dashes, and in the new file, it's with the slashes. So let me just explain what we did here. We started off with the imports that we need, CSV and the datetime class for the datetime module. We then created a function to convert the dates. This starts by extracting the date field from the record and then uses that datetime strptime function to parse the date field. The format string, which is percentage capital Y and percentage lowercase m, percentage lowercase d, tells it to select a 4-digit year, which is percentage capital Y, followed by a hyphen, followed by a 2-digit month, which is percentage m, lowercase m, another hyphen, and then a 2-digit day, which is percentage lowercase d. That produces a date object. We then use the datetime.strftime function to format that date object in the required format by rearranging the fields and using slash as a separator. So note that the datetime versions of strptime and strftime do not have the parameter order anomalies of the time module versions. Finally, we replace the original date field with a new string and return the modified record. The main code of the script opens the original CSV file, reads the records, and stores them as a list called items. We then replaced items using a list comprehension that called our convert date function on each record in items. And finally, we wrote the modified items into our CSV file called tooldesk2.csv. So we can try to load this new file into Excel. Delimited, comma, so this shouldn't be there, it should be here. And we can get the date format correct. And so far we have been using the basic reader and writer components of CSV module that work with lists of data items. We may recall from earlier that CSV also supports a dictionary-based approach. We now use that to access the original tool hire CSV file. If we look again at the contents of the CSV file, which is this one. Oh, sorry, it's tool hire, so a CSV file. Let me just close this to not make it too confusing. So if you look at the content of the CSV file, we notice that the first line is a list of headings that describe the columns. The CSV module can exploit that by using the headings as keys in a dictionary, and this makes accessing individual files much more reliable because you no longer need to rely on the numeric position of the field in the file. And the way it works is very similar to the previous code. When instead of using a csv.reader object, we use a csv.dictReader. And let's try that in our command prompt. So notice that it is normal with a dictionary. The fields are not in the original order, and they are keyed using the labels from the first line. You can see that as before, the scarifier description has lost the quotes but retained its comma. And if instead of printing the items we store them in a variable, we can do some interesting analysis of the data using list comprehensions. Let's say to see all of the items owned by Fred, we can simply do this. So it gives us that the owner of these two items is Fred, or it gives us the items where owner is Fred, and that's lawnmower and sprinkler. Sprinkler is the sprinkler, and the owner is Fred, and lawnmower and Fred. Yep. We could do the same thing using the basic reader and its lists, but you would need to use numeric. For example, the tool desk 2.csv file that we created in the previous example had no label line. So it does not have any label line. And we can remedy that by reading it into a dict reader and then writing it out with a dict writer. The trick is to provide the labels as an argument to the dict reader constructor. So let's create a file, a new Python file, which adds a set of labels for the tooldesk2.csv file, and then open the file and read it into a dict reader object. We then write the data out to a new file using a dict writer that automatically inserts a label heading row. So let's create a new file, Python file. Let's call it add labels. Just note that this file does not have any labels. So the fields. So open the file. And note that there is no tool-desk3 file. Let's save this and run it. Okay, created a new file here. So you can see. Let's see how it looks. And it has the labels added. That's good. It has all the headings that we specified up here. So what happens here in this code, I'll explain it now. So after importing the CSV in the first line, we define the field names as list of strings. We then open the original file called tooldesk2.csv and read it into a list called items using the dict reader that had been initialized with our fields list as its field names parameter. And the next step was to write this out to a new file with a header line. To do that, we opened a new file, tooldesk3.csv, and created a dict writer object specifying the desired order of the fields via the field name parameter. Remember that a dictionary stores the fields in an arbitrary order. We simply pass the same fields list that we use to read the file, thus maintaining the same order. We then call the write header method of the writer object and follow that by using the write rows method that writes out the entire items lists in one go. So now we have seen how to use the CSV reader and writer objects to convert between the CSV file format and Python lists, as well as the dict reader and dict writer objects to do the same with dictionaries. We also seen two examples of modifying a CSV file format to make it more suitable for subsequent processing. The CSV module contains a few other features for dealing with non-Excel based CSV files, but you can read about those in the documentation if you need them. So now I'd like to talk about working with config files. And config files, as they are often called, Windows INI files, have a very readable format that is also easy to work with programmatically. And they have fallen out of favor in recent years because Microsoft now advocates the Windows registry, and non-Microsoft applications are moving to XML based storage. However, there are plenty of legacy applications around that use this format, and they search for .ini on a relatively clean installation of Windows 8 or 10 can lead to find several hundred files, so it's far from dead. The format is very good at storing multiple instances of similar data, such as per node settings on a network, or for multiple categories of options, such as various screen sizes or online versus offline operational parameters. The disadvantage of the config format is that it can sometimes be too simple, with the result that complex data is harder to fit into the format. And Python provides the config parser module for reading and writing config format data. And one note is that the config parser module is one that has had a name change for Python version 3. In Python version 2, it was known as config parser with capitalized C and capitalized P. But in Python is all lowercase, config parser in lowercase. So if you are working across Python versions, be aware of the name change. The functionality remains the same. So let's just, I'm just going to give you a simple structure of a config file. Etc. So the default section is noteworthy because options defined there apply to all following sections. The format has a lot of flexibility, with spaces and indentation optional, embedded sections, and various other variants, including the ability to interpolate a value from one option into another option. And the config parser module can handle all of these and much more. It converts the data into or from a dictionary format similar to the kind used for the CSV files described in the previous exercise that we did. Basic usage is shown very clearly in the documentation with examples of creating a file and reading from it. Because there is little point in repeating that here, we can browse it at our own leisure and then try it out. So let's try to create a read config file. So we'll do a small example where we create a config file, such as might be used for the tool lending application that we are working on. This config file describes the standard settings and any user-specific overrides to those values. The settings are limited to the lending period expressed in days and the maximum value of items that can be borrowed. 0 implies no limit and is the default value. So let's go into the parser, the Python interpreter. I'll just quit and restart this for like always. I'll explain in a second. This will create a new file. So this should have created an ini file. It's here. So if we open it with our text editor, I'm just going to use Notepad. And it's created as expected. Now let's try to interact with this file. So here we get rid of the old values. Create a new instance. Checking what are the default values for max value. Should be 0. And let's try to investigate a bit of irregular behavior. Because Joe doesn't exist. There's no section called default. So what we have done here, after importing the module in the first line, we created a config parser object and then assigned a dictionary of name value pairs to the default section. And we then stipulated a limit on the value of what Fred could borrow. Let's say he has a track record of breaking things, as well as a limit on Anne's lending period. Maybe she tends to forget to return things, so she needs a reminder. We then opened the file toolhire.ini in write mode and used the config parser object to write the data to the file. Having checked that the file existed and contained the correct data, we then set about reading the data back from the file. In preparation for doing that, we deleted the original parser object and created a new one, reusing the name conf. We use conf to read the toolhire.ini file. We checked that the expected sections were available and saw that the default section was not included in the list. We then read some option values from the parser and saw that we could read the default values even though it was not listed as a section. Furthermore, the default values are used when a particular option is not explicitly declared for a user. For example, the default max value is returned for Anne even though she only had lending period specified. We then tried pushing the boundaries a bit to see how the parser handles error conditions. The first attempt was to access a user for which no values had been provided, Joe. This gave a typical dictionary key error. We then read the available options for Anne and discovered that the parser returned the default values as well as those explicitly defined. And we also discovered that option did not work for the default section, and we needed to use the explicit defaults method to fetch those options. The non-standard behavior for defaults is one of the few annoyances you will experience in using config parser. And the next thing I'm going to talk about is working with XML and HTML files. So you are probably familiar with HTML as a language of web pages. XML is also widely used as a so-called self-describing data format. XML and HTML are closely related formats. XML is much more rigidly defined format, and that makes it easier to process using a computer. HTML is very forgiving of malformed content, and although that makes it easy to create by hand, as well as with specialized editors, HTML is much more hit or miss to process accurately. HTML also has many variations because of web browser proprietary extensions. All of this means that HTML parser have a trickier job and often yield less than perfect results when faced with badly formatted files. Because XML is easier to handle programmatically, you look at parsing it first and then extend the technique to cover HTML. That's what we'll do. One note is that a form of HTML known as XHTML is also valid XML. XHTML is starting to appear on website as increasing number of web publishing tools support it. This means that you can use XML parsers to parse XHTML as well as other forms of XML. However, HTML5 has in fact deprecated XHTML, so its use in the future is likely to diminish rather than increase. So let's talk about parsing XML files. Many different parsers are available for parsing XML. The Python standard library contains no less than 5, which are called I'll write it out here, DOM, mini DOM, and you have the XPath, and tree, and the sex. These all fall into two categories: those that read the entire file into a tree-like data structure called a document object model, or DOM, or those that read the file looking for items of interest, like an event, and triggering a response as the items are found. The former are more flexible for complex or multiple queries on the same set of data, and the latter tend to be faster and slightly simpler to use. So in this course, we only look at two of the parser, each representing one of these two approaches. The first parser we are going to consider is Sax, which is an example of an event-based parser. To understand how event-based parser work, we'll try out an example that parses some plain text. So I'm just going to write some text. That was one function. Then we have the parsing function. So what we did here, we created some text that we want to parse. We then defined a function has_Mary that we want to be called every time Mary is found in the text. Next, we create our event-driven parsing function called parse_text. This function iterates over the input text line, over the input text line by line. If the search string, in this case Mary, is found, then it calls the function that has been passed in. We then execute parse_text with our text string and the hasMary function as arguments. It prints out the 2 lines containing Mary. And the sax module works in a similar way to our parse_text function. However, it uses events such as detecting the start of an XML element rather than plain text patterns. It takes an XML source text and a collection of events and associated event handler functions. It then processes the XML text section by section, and if it finds a match to a given event, it calls the associated handler to deal with it. The parser does not store the XML data, it simply iterates over it. So if we need to go back to access earlier data, we need to reparse the entire file. So to investigate the sax parser, we need an XML file. And I have already an XML file here. So I'll also put that up in the course description of this lesson, where you can download it. And this is simply an XML export of the tool hire Excel spreadsheet that we used earlier. So it looks like let's just view it in Notepad. So looking at the XML file, assume that you want to find the average length of loan. We use sax to extract just the date length and date return fields. For each item and store them as a tuple in a dates list. We can then later process those dates to find the duration of each length item. To initialize the parser, we need to create our handler and specify the events that we are interested in. Sax actually uses a handler object, an instance of the xml.sax.handler.contentHandler class, or more specifically a subclass of it, to combine the event and function. Several predefined handler subclasses exist, including one for dealing with errors. The advantage of this approach is that many default methods are already defined and others can be easily overridden, such as start document, called at the very beginning of parsing, and useful for setting up state variables and the like. For simple XML parsing tasks, you normally create a custom subclass of content handler and then write your own version of the start element and end element, and also possibly the character methods. By inspecting the XML file, we can see that the data that you want is contained in a data element. And is identified by the ss.type attribute being set to Datetime. and the actual data is character data that it sits between the start and end of the data tags. So the expected event sequence is start element followed by character followed by end element. So let's try to create a small Python file. Let's call it to hire sex. So I'll start typing in the code. The IDE gives us all the help that we need. Set up some initial variables. Like always, I will explain at the end what I'm doing. me. So I just checked the file if it doesn't have any errors. Let's see if this works. It seems to work. So the initializer, I'll explain the code now. The initializer calls the superclass initializer and then sets up various data attributes that we use in the parsing and need to use across methods. It also creates an empty dates list to hold the results. The main parsing method is the start element method that looks out for data elements, and when one is found, refines the search by selecting only those with the SS type attribute of datetime. We have to identify these values by inspecting the XML file manually, because you can have up to 2 dates in a single row. We use the self.date counter to keep track of which date within the row we are handling. We use the self.isDate value to indicate the character method that it is inside a date element. If the data is not a datetime type, then we reset the self.date counter to 0. The end element method ensures the self.isDate flag is reset to false, ready for the next start element event to come along. And the character method ensures is called whenever content outside a tag element is encountered. We are only interested in the date information, so if the self.isDate flag is not set, we simply ignore the character data. So if the data is a date, then we check if it's the first date, in which case you store it in the self.datelength attribute. If it's the second date, we store both dates in the self.dates list. If only one date is found, the character handler is not called a second time, and the date is not added to the dates list, thus ensuring you store only pairs of dates, which is what you need for duration calculations. Finally, the driver code at the bottom creates the handler and parser instances. It then sets the handler within the parser to your tool higher handler instance and executes the parse operation on your XML file. After parsing is complete, it prints out the collected dates from the handler. We repeat this exercise until using the elementary DOM-based parser. you can compare and contrast the two techniques. First, though, you look at the parsing HTML, because the standard library HTML parser is very similar in style to the Sax XML parser. So let's try to work with the parsing the HTML files. The standard library provides the HTML parser module for parsing HTML. It works in a similar way to the Sax parser in that it is event-driven. It is slightly simpler to use because it only has a single class with the handler methods defined within it. To show it, how it works, we once again extract the dates from the toolhire.xls spreadsheet, but this time from the HTML export. And I've already done that. I'll also put that file in the download links. So let's try to open it. I'll open it in Notepad. Sorry, I was looking at the wrong file. It's a file called sheet 001. That's what we were supposed to work with, not toolhire.html. So looking at this file, we'll see that we can see that the dates have a unique class named XL65. This means we can look for the TD tags with that class attribute value in a similar way that we did with the earlier XML example. The HTML parser class works very like the Sax content handler class in that it has methods corresponding to HTML document elements. So in the example that we are going to do now, we override the handle_start tag, handle_end tag, and handle_data methods that are directly analogous to the start element, end element, and character methods of XML. So let's try to write some code working with this file. Create a new file, new Python file. Let's call it HTML. Just close the ones that we don't need anymore. Very similar to the code that we did. It's not list, it's supposed to be empty. rename this. So it is XL65, not X165. To get the indentation correct. First we need an end tag. Just found one typo. And then I need to this. Indentation must be correct. Let's see if this works. Yep. So if we compare it with the Sachs example, we see that the code inside the methods is nearly identical. The HTML parser presents its attributes as a list of tuples. We iterate over that list looking for a class attribute of value XL65 to identify the date field. And remember, it's XL, not X1. And that this is an export from Microsoft Excel, hence the class name. The parser conveniently takes care of mixed case HTML tags, or by converting tag names to lowercase, so you don't need to worry about that. It also does its best to make sense of badly formatted HTML, although it's not perfect and really bad code can trip it up. So this is the conclusion on this section on reading data files with a look at another of Python's XML parsers. So we are going to look at the element tree, and we investigated in the next example. What we are going to see here is that we use the element tree XML parser to extract the same set of dates that we did in earlier examples. We also use the data to calculate the average loan period for the items in the spreadsheet. So let's start creating a new file. So let's create another file. Python file. ET for element tree. Like always, I'll explain at the end what I'm doing, because we will also be creating another function for calculating average date. dates. And for this exercise, we'll use the toolbar XML. We'll also put that in exercise files for you to download. Let's see how this works. So it's given us the dates, which is correct. So we need to create another file. Where we're going to calculate average loan period for what's the average loan period from these files. Here. This should be the correct format. Date. It. Nope, that's not correct. Actually, what we can do, we can actually put this function instead of putting it here. We can put it in our file here. So we don't need that. Yeah, we don't need that actually in a separate file. So this should work. Yep. So it says here that the average loan period is 44 days. So let's go over this file and go over what's going on here. So we started by importing the element3 parser and assigning it as an alias et. We then imported the datetime module as dt in anticipation of the date calculations to follow. We created a parse dates function that starts off by parsing the XML file into a DOM. Notice that the parse function takes a file name as an argument, not a file object. We then obtain the root node from the DOM using the getRoot method. We use the iter method to find all nodes, as signified by the quote argument. We then inspected the node, and if it had row in its tag, we added the node to the rows list. Having built a list of rows, we then drilled into each row and examined the cells. We checked their attributes looking for a key of type with a value of date time. Once found, we inserted the date nodes into row underscore dates list. At the end of each row, if the row underscore dates list contained 2 dates, we added it to the dates list. Otherwise, we just ignored it. Then we returned the final dates list at the end of the function. We then tested the function and checked that the output was expected list of dates that we did before. And then we added the new function calculate average and modified the main function accordingly. In the calculate average function, we initialized a list to hold the length of each row. We then iterated over the dates list, extracting them in pairs. We knew the pairs match because we only added pairs of dates in the parse dates function. The extraction process involves splitting the date strings on the letter T and only keeping the first part of the string. We had to split the strings because the date.strptime method cannot handle the decimal seconds value. The next step was to convert the date strings into datetime objects using the strptime method. We then used the datetime object's arithmetic capabilities to compute a time delta representing the loan period and stored the days value in the loan underscore period list. And finally, we calculated the average of the stored periods and returned the results. Some applications do not lend themselves to generating data files. In these cases, we may need to interact with the program via an application programmer's interface, an API. So in the next lesson, we are going to work with accessing native APIs with C types and Pywin. So see you in the next lesson. This was a very long lesson, but there's lots of here to take in and lots of information and practicing. So I hope you enjoyed it, and I see you in the next lesson.